Hello, my lovely Year 12s, and welcome to Area of Study 1, which is consciousness. Remember, we started with Area of Study 2, which is memory. So now we're going back to Area of Study 1, which is where the rest of the state would have started. Hopefully you'll find this area really interesting. So consciousness is the state you're in at the moment, or you are conscious at the moment, which means you are aware of both your internal and external state. And any thoughts and feelings you might have about them. So something that's happening in your external environment is my voice and the PowerPoint, and your internal environment might be your eyes focusing on this PowerPoint, your heart rate, perhaps you're hungry and your stomach's grumbling. But you've got thoughts and feelings about both of the things that are happening in your awareness. Throughout the day, our level of awareness or consciousness will vary. So for instance, you'll be at points during the day where you have a high level of attention or awareness, and of course this is when you're in my psychology class, and then there'll be other times of the day where your level of awareness would drop, and that's usually when you go to sleep. But the continuum continues right down to being unconscious or in a coma. But ultimately in a normal day you would still vary within a normal range. Your level of awareness of internal events and how that changes is referred to as states of consciousness or a state of consciousness. So at the moment, if you're focused, that's a type of state of consciousness, and later tonight when you go to sleep, that's a different state of consciousness because your level of awareness has changed and you've moved up or down that continuum. Okay, normal waking consciousness is the state that you're in at the moment. So this is what we describe as when you're organized, clear, and and all of your thoughts are quite meaningful. You're awake, you're aware, and you're carrying on life as normal. So that's usually, during the normal waking hours, we tend to spend most of our time in this state. It's different to an altered state of consciousness in 6 different ways, and we would have spoken about this in class, so hopefully this will make some sense by the time you're watching the video. So a normal waking consciousness, we can control the content that comes into our mind. So if there's an unpleasant thought, we can push it out, but perhaps we can do this as well when we're asleep. When we're in normal waking consciousness, we can carry out both controlled and automatic processes. Controlled processes can become quite hard in some other states of consciousness. Our perceptions are very accurate and logical, and we don't tend to experience any cognitive distortions in normal waking consciousness. We're aware of our emotions, we can control our emotions, and our emotions are appropriate for the situation. We have self-control both over our own thoughts and feelings, but also in terms of our muscles and movement. And we usually have a pretty accurate perception of time in normal waking consciousness. But we know that these 6 things can differ in an altered state of consciousness. So an altered state of consciousness is any state that deviates from normal waking consciousness. A bit of a vague definition, but that is the definition. Examples of altered states of consciousness include things like meditation, hypnosis, psychosis, daydreaming, and so on. And we know that some of these we can choose to enter into. So for instance, if you decide to take drugs or drink alcohol, you are deliberately inducing an altered state of consciousness, or perhaps others can occur quite naturally. So for instance, when you go to sleep, that's a naturally occurring altered state of consciousness, and same with daydreaming. Consciousness is what we call a hypothetical construct in that you can't directly measure it or observe it. So for instance, I can assume you're daydreaming in class when you look a bit vague and you're staring out of the window, but ultimately there's no way to prove that you actually are. I could ask you for a self-report, but even that wouldn't necessarily be accurate because you might think you were paying attention. But it's very hard to grab hold of consciousness. We believe it's there, but we can't directly measure it or observe it. We do use 3 main devices to help us try and get some knowledge about state of consciousness. And from using these devices, we then try to infer on what's happening with the individual. And the three devices are EEG, electroencephalograph, EOG, electrooculograph, and an EMG, which is electromyograph. So the EEG is about brain waves, the EOG is about eye movement, and the EMG is about muscle movement. We could also use heart rate, body temperature, and galvanic skin response, but you'll see a little bit later in this presentation why there's some issues with those three. So an EEG detects, amplifies, and records electrical activity in the brain in the form of brain waves. You'll see that I've written the word DARE there, and that's an acronym to help you remember how you need to explain what it does. So D for detects, A for amplifies, R for records, and E for electrical activity. So anytime you get asked a question like this in the exam, you must use those words. Electrodes are basically put on the skull, and these electrodes pick up the tiny amounts of electrical activity that are generated by our cells in our brain, and then they're displayed in the forms of brain waves. Brain waves can be described according to their height and speed. Their speed is called their frequency, and their height is called their amplitude. So there are 4 different types of waves that we emit. So beta waves are high frequency, so quite fast, and quite small, low amplitude waves. And we typically have these waves when we're alert and active. Alpha waves are slightly higher, reasonable frequency, but a bit slower than the beta waves. Low amplitude, but slightly higher than the beta waves. So they're a little bit bigger and a little bit slower than beta waves. And these are the ones we tend to emit when we're awake but really quite relaxed, or we're about to fall asleep. Theta waves, medium frequency, mixed amplitude. We tend to get these messy type waves in early stages of sleep. And delta waves are very low frequency, so they're very slow, and they have a very high amplitude, so they're very large waves, and we typically see these in the deep stages of sleep. If you have a look at these graphs, it gives you a visual of what those 4 brain waves look like. You will have to know these waves and be able to identify them, but we'll spend a little bit more time in class on them as well. An EOG, same acronym, so DARE, it detects, amplifies, and records electrical activity in the muscles that move the eye. Be very careful not to say that it detects electrical activity in the eye. It's actually detecting the activity in the muscles that are attached to the eye that then move the eye. And the reason we tend to look at EOGs is because it can detect the difference between REM sleep, rapid eye movement, and non-rapid eye movement sleep. And you'll see this when we go to the sleep lab during the week, and we'll actually see it in practice. An EMG detects, amplifies, and records electrical activity of muscles, and the muscles that they tend to measure are the ones under the chin, although they could really use any other muscles. And again, this is useful in detecting what stage of sleep we're in, so REM sleep versus non-REM sleep, and that's because when you're in REM sleep, you tend to have what we call REM paralysis, where your muscles don't move at all. So if the EMG is showing muscle movement, you're probably in non-REM sleep, but if it's showing little or no REM muscle movement, you're probably in REM sleep. So that's another measurement device we can use. We can also look at the heart rate, body temperature, and galvanic skin response, and you can have a quick read about what those 3 are. The problem is that these 3 can be changed regardless of state of consciousness. So for instance, if you're exercising, your heart rate will go up, your body temperature will also go up, and so will your galvanic skin response, because it will measure the electrical conductivity, and this changes depending on the amount of sweat we have present in the skin. So all these 3 things could change when you're exercising, which could then indicate you're in a different state of consciousness. But we know that's not the case, you're just actually exercising. Same thing that if you're sitting in a hot room, you might find that these things change again, but not necessarily a state of consciousness. So we would never use these measures alone. And just to finish up for this PowerPoint, I thought that was a really interesting little point to put up there. So a psychiatrist who did an experiment of people and put them in the dark 14 hours a day for a whole month to see what their natural sleep cycle would be like. And by the 4th week, they'd basically settled into 2 lots of 4 hours sleep instead of the typical 8 hours sleep that we have now. That used to happen centuries ago, and by about the 1920s it tended to be phased out, and now all of a sudden we accept our sleep should happen in one big block, but perhaps that's not the correct way. Looking forward to seeing you in the next PowerPoint. Hope you enjoy this area.